Hi everyone. Okay, we have to continue discuss the questions of this worksheet. Can you please take this worksheet out review? We will continue right now. Okay, next question. Which reaction will give 2 chloropropane in the best yield? So, when you look at this word best yield, which means you're not going to get any side products or alternative products, okay? So, now let us look at the options one by one. Propane gas with chlorine gas in the presence of ultraviolet. We know that this is a chain reaction, right? Free radical substitution reaction. So a mixture of products are going to get right? Because the point is the propane gas, any hydrogen atom has equal chance to be substituted by chlorine. So you will get a mixture of products at the same time, okay? Of course, the yield will not be that good, right? So this should not be the answer. And this one, as I told you, propane 2O, if you want to substitute the OH group with the Cl group, we are not using NaCl. Instead, we just learned it. We can use HCl, we can use SOCl2, we can use PCl3 upon heating, and we can use PCl5 at room temperature, right? But the alcohol doesn't react with NaCl only. Okay, remember. You will see a lot of questions like that in MC to trap you, okay? So only any one of these will react with OH, okay, to replace the OH by Cl. And this one, of course, can you see that? This one echoes with this one. So this most likely will be the answer, okay? Because propane 2O, I try to write here, C. Propane 2O, if you add SOCl2, you will successfully replace the OH by Cl. So the yield is good because this is the only organic product formed, okay? Propane with dilute HCl. Basically, you can get 2 chloropropane, but at the same time, you will get 1 chloropropane as well. Do you still remember the Markovnikov's rule, right? So both will happen, only the 2 chloropropane will be the major product, but you still have the minor product. Of course, in this way, the yield will not be that good. So you have propane, right? Yeah. Propane, right? So if you add HCl, you will get 2 products. One is this one, that is the major product, and one is this one, that is the minor product. So they will come up at the same time, so the yield is not good. So the answer should be C, okay? Oh, this one. What will react differently with the 2 isomeric alcohol? Now you can draw the alcohol out further if you cannot see clearly. So one is like that. And this one will be like that. So that they both end with a primary alcohol, okay? Okay, look at this. Acidified aqueous potassium permanganate. This is not the answer because both of them will change this group to COOH. Okay, so they react at the same way. Okay, right now the question is asking react differently. Differently can imply when one has reaction the other one doesn't have, or they undergo different kinds of reaction with the same reagent. Okay, so concentrated sulfuric acid. Let's look at concentrated sulfuric acid. As we know, is a dehydrating agent, so it's going to remove the water. Well, this one is going to remove the water from taking one H from here and the OH from here. Okay, so you will get, if you add concentrated sulfuric acid together with heat, you will get an alkene here. Okay, an alkene here. But this one, as I said, you have OH for at this carbon, but at this carbon there is no OH, no hydrogen atom. So in this way, you cannot pour out the water because the water is formed when one OH is eliminated from one carbon and the other H is eliminated from the carbon nearby. So since there is no OH, so there will be no reaction for B, for concentrate sulfuric acid. Then obviously the answer is this one. But we can also take a look on C and D. For C, they will have the same reaction. The OH will be replaced by the Cl. Both will have the same reaction. For D, the same. The OH will react with sodium to form alkoxide ion, right? So the reaction are the same. So the answer is B. Is the because it doesn't show any reaction with this one, no reaction, but it has reaction dehydration with this one. Okay. 好 Which isomer forms free alkene on dehydration? Now, this one 3, okay, you will have to consider the cis trans as well. Cis trans. Okay, the answer is actually B. We can look at this, okay. Why is this the answer? Now, propane 2O, right? When it undergoes dehydration, it will form either this one, because you can capture the H and OH here, or it will form this one, because you can also capture the H and OH from here, right? And this one, remember, because each carbon atom is bonded to 2 different atoms or groups of atoms, so it can further exhibit cis and trans. So 1, 2, 3, then this is the answer. Okay, now we can look at A and see why A is not the answer. I don't have enough space, so I will write here butane 1O, right? Butane 1O. Yep, 2, 3, 4. Butane 1O. After dehydration, you will pull out an OH here and pull out a hydrogen here, right? So it will become this one. Now, since for this carbon is bonded with both H, so there is no cis trans. Then of course, if there is no cis trans, there is only one pointed form instead of 3 isomeric form. Okay. Likewise, you can also see try this one and this one. I try one more to you. I don't want to try all. Okay, 2-methylpropane 2O. Okay, let's take a look. Okay, 2-methylpropane 2O is like that, right? So when you remove the water, okay, you're going to remove from either here or here, but it's the same because it's symmetrical. Can you see that? So in the end, you will get something like that. This one, okay, this is a methylpropene. Methylpropene. And methylpropene doesn't have cis trans because this H, but this carbon is bonded with H and H, okay? They are of the same kind of atom, so of course it can't exhibit cis trans, okay? So the answer is B. Okay. Huh? What happened? Funny. Okay. Which structure show a primary alcohol that cannot be dehydrated to form an alkene? Now, in order to finish dehydration, as I said, you need 2 carbon atoms. One is bonded with H, the other one is bonded with OH. Keep quiet. So the water will be pulled out from here, forming alkene. Okay. Now let's take a look. Shows cannot. So this one, it only has 1 carbon. Of course, if it only has 1 carbon, you can remove the OH from this carbon, but you cannot remove the H from the other carbon because it only has 1 carbon. Okay, only 1 carbon. So it cannot undergo dehydration. This one, obviously, you can get 1 OH from here and 1 H from here. What happened? And 1 H from here. So it will get Sorry, it should be. Is this a rubber? Okay, sorry. Okay, you can get one OH from here and one H from here. So you will get edine, right? Dehydration occurs. So this is not the answer. And then cannot, so you pick the coarse one. And this one, of course, you can also undergo dehydration because this OH is bonded with this carbon, and the carbon nearby has hydrogen. So you will get, okay, you will get propene. So only one. So the answer is D, only one. Okay, you can go back to the instructions at the beginning of this page. Okay. How many of the isomeric alcohol with the formula reproduce an alkene that has this chance on treatment? Now then we have to draw them all out, okay? So the first one is this one. As I said, after dehydration, you will get this one, B1N, right? B1N is bonded with 2H on this side, so cannot exhibit this chance, okay? And then sorry, one here, right? So you can see this is 1, 2, 3, 1, 2, 3.